In this class, we'll try to learn about the comparison of the power devices. So now let us see here the power devices. Different kinds of power devices, as we earlier we have seen it, and we also studied about those um, in detail. But right now, in this particular lecture, we'll be studying about the comparative analysis about the power BJT, MOSFET, and the IGBT. Power BJT, MOSFET, and the IGBT. So now here, first one. Let us see the first one. It's a symbol. The symbol of your BJT, power BJT, it looks like this, where it's an first one is for the NPN BJT, and the next one is for the PNP BJT. It's NPN and PNP BJTs for symbols. And next one, MOSFET. It's an first one. It's an N-channel MOSFET. N-channel MOSFET, where you can see the arrow mark. It's into this one, into the gate, towards the gate. And for the P channel, the arrow mark will be away from the gate. Similarly, here for the power BJT also, the arrow mark will be at the emitter, where the arrow mark will be towards the base for, for the PNP transistor. And for the NPN transistor, arrow mark will be present at the emitter, which will be away from the base. Next, go to the IGBT here, insulated gate bipolar transistor. Here, this is a structure where it is a combination of MOSFET and the bipolar transistor. It's why I'm calling it a MOSFET, because the gate is insulated. This is a BJT and this is a IGBT, where it's nothing else but it's called as an insulated gate bipolar transistor. So both, just like the bipolar transistor, which has got emitter and collector, even this one has got an emitter and collector, where the arrow mark is away from or towards the emitter, just like your NPN transistor. And instead of, there is an extra terminal which is connected near the base over here. This is a that terminal we call as a gate terminal. So this is the differences between power BJT symbol, MOSFET, and the IGBT. Coming to the type of the uh, device. In the power BJT, the carriers will be minority carriers. In the MOSFET, it's a majority carriers will be there. And even in the IGBT, the carriers will be type of the device will be, it works upon the majority carriers. Okay, right. Then now here, talking about the temperature coefficient. For the BJT, temperature coefficient is negative. For MOSFET, it's positive. And for the IGBT, it is a flat one, flat temperature coefficient. Talking about the voltage blocking. Regarding the voltage blocking and different kinds of blocking operations, we'll be studying in the thyristor concepts. But as of now, for this one, voltage blocking in a BJT, it's asymmetric. For the MOSFET, it's asymmetric. And for the IGBT, it can be symmetric or it can be asymmetric. And operating frequency, which is the most important one. So we are supposed to design this MOSFETs or IGBTs or the power BJTs at some particular MOSFET. So now here the operating frequency for the power BJT will be 10 kilohertz. For MOSFET, it's 100 kilohertz, and for IGBT, it's 10 kilohertz. On-state voltage drop. The next one is on-state voltage drop. For power BJT, it is less than 2 volts, 2 volts. For MOSFET, it's 4 to 5 volts. Voltage drop will be 4 to 5 volts, and for the IGBT, it is 3 volts. And next, going to the snubbers. Snubbers are required for power BJT. For MOSFET, it's not required, and also for IGBT, it's not required. Coming to the eighth one, it's a VI rating. VI rating is one of the important parameter. We are supposed to know what is its current and voltage rating and also power ratings. So now for the IGBT, for the power BJT, the first one, the power BJT, VI rating is first like voltage 2 kilovolts, and for current it will be 1 kilo amperes. This is a voltage rating and this is a current rating. So now current voltage rating of the power BJT is 2 kilovolts and current rating of the power BJT is 1 kilo ampere. Just similarly, for if we go for the MOSFET, it is 600 volts is a voltage rating for MOSFET, and 200 amperes is a current rating for the MOSFET. And coming to the IGBT, in this IGBT, you will be studying about voltage rating has 1500 volts, and for current rating will be of 400 amperes. So these are the voltage and the current ratings of power BJT, MOSFET, and the what is the other one is the IGBT. Next, coming to the applications. Applications here, your Power BJT can be used in UPS application, SMPS application, static wear system applications, and again AC motor control applications. So these are the few applications which have been mentioned over here. There are many other applications, but these are the for applications where you can use the Power BJTs like UPS, SMPS, static wear systems. Then again AC motor control. The next one for the MOSFET, MOSFETs can be used in AC motor control. Coming to the IGBT, IGBT can be used in SMPS, drivers, and AC motors. So these are the few what comparative analysis of power BJT, MOSFET, and also IGBT. So this is about the comparative analysis of what is how we can analyze the power devices. So we have seen different power devices in the earlier lectures, and for those power devices like power BJT, MOSFET, and IGBT, we have made one analysis over here, and these are the comparative analysis of three power devices. I hope it's clear to you.